I made the world's most expensive intake manifold gasket, and I'm an idiot for doing it. Stick around. What is going on, everybody? Welcome back to the garage, and it's been a while since we've done anything on the Typhoon, and one of the big things that's been happening on this is right before, like the day before Rocky Mountain Race Week, we were supposed to load this up for 1.0. Had not, I guess technically an oil leak, but I thought it was a valve cover leak. It turned out to be the intake manifold in the intake manifold gaskets. And so what I have been spending the last almost month on is creating my own intake manifold gasket for the Typhoon lower intake manifold to Vortec heads. And I've got everything down here. We're going to show you why this is the Vortec head gasket. Unfortunately, I don't have a Typhoon, but I do have a lower intake manifold that we can compare this to. And then this is the multi-layer cork and fiber gasket that I have created using the Vortec layout. And there's a couple things I want to show you as to why we did this, why it cost so much money, lasers, and why it took so long. So I'm going to cut down here to the intake manifold so you guys can get a closer look and see some of the issues that we ran into whenever installing the lower intake manifold on the Vortec heads for the Typhoon, and why we had to resort to doing custom intake manifold gaskets. Okay, hopefully you can see everything all right. Here is our Vortec or our Typhoon intake manifold. Here's one of our Vortec gaskets, and here's how it would go on there. Now, the big thing to take away from this is going over to the Vortec heads, you can see that there's a big gap on the top here. The ports are so much bigger on the Vortec heads. And whenever you get a lower intake manifold that has been modified to go to the Vortec heads, they're going to weld up this side of these ports to give you more space. I've got some pictures over on Instagram showing where I have ported these out with the built up edge on these things to hit these gaskets. Now, that's all fine and dandy. Those spots are built up. There's some small areas that weren't built up, specifically around the water jackets. Not an issue on the backside, except that there's a hole right there on this gasket because the water port's too big. And on the front side, there's a hole because the water port is too big also, which if you look at it, that's a small port. That's the same size port that's on the Vortec heads. Maybe a later head used this bigger water port on there, but it's way too big. That was one of the areas that was causing issues, and we tried to build that up by TIG welding it and grinding it down. But this is the main area where the problem was, I think, rearing its head on getting this thing to seal up properly. There's some other funny stuff going on, like these notches that are cut in here that could be potential leak sources because of this being a rubber and plastic style gasket. So that's something else that may have been an issue. But as you can see, this big block right here, there is no rubber on that. I tried to RTV this down to the head and the intake manifold. I don't know that it's sealed. And I think we were getting most of our exhaust leak, our crankcase vapor leak out of this area. And it's just not feasible to really build all that up straight across. Whereas on the Vortec heads, our lower intake manifolds, that is a straight run across there, and that would seal up better. So here is our multi-layer gasket that I have made. As you can see on the back side here, we have blocked off the water jacket that does not exist on the V6 heads. V12s are V12s. The V8s would have a rear water jacket on it. These do not. On top of it, it is the same port size. I have not done the bolt holes yet. I want to get this thing on the head, or on the valve, the heads, and mark out the holes that way. But the ports are the same as the Vortex. And then the water port up here, I measured that and made it the size of the one that's actually, let me scoot it over, the one that is actually the size of the jacket in the manifold. So, as I said, here's kind of our template. Here's what we ended up with. The thickness compressed should be about the same. We should still have enough compression on there. And that's another issue that you run into that keeps you from really running just the Typhoon intake manifold gaskets. They're too thin. They're just a single layer of fiber, and this thing needs to be set off about 1/16 of an inch on both sides so everything lines up appropriately with the Vortec heads. So let's take a look at the equipment that we used in order to get this done. Okay, if you followed me long enough on the channel, you know that I've been doing a lot with my little laser etcher on here. And this thing's fun. It's a little, I don't remember, maybe a 40-watt module, 30-watt module. Pretty small, multi-focus, and it had a fairly small build area. Like, this is, you know, kind of your maximum build area that you're going to be able to get to. And it just was not making the cuts that I wanted to make. So I upgraded to this thing, the SculptFun S9. And technically, this laser is a smaller laser, even though the module itself is way bigger. But the way it uses the focusing on it, it works like a 90-watt laser. And in fact, it will cut through, you know, wood pretty decently, and you have to play around with it. So that's what took so long. This was a learning experience of like trying and failing and trying again. So like, here's our center section that's going to be for our next gasket. Here are the fiber outsides, and to cut something like this, it may take tweaking the settings and doing, say, like 6 passes at a certain rate. On top of it, I went online and I 3D printed this thing, which is an air assist nozzle. You got a little hose on there. You can probably see it over here, this little hose that I've got running over here. I hook it up to the air compressor, and what it does is it blows air out as the laser is cutting this stuff. It keeps the channels clean, the cut channels clean, because if you don't do it, you can see here I've got one that failed because I didn't have air assist on it, or I didn't do it long enough. It won't get all the way through the material because the soot will get built up in the channels and clog everything up. So I cut, as an example, just all kinds of stuff. These are all parts from test cuts, more parts from test cuts. Here's another test cut manifold or gasket that was pretty close that I made some tweaks to. You know, it was a long process. Whenever it was all said and done, cutting these two pieces, which I was able to cut both at the same time from one piece of Fel-Pro gasket material, took about 4 hours maybe. It is a slow process. You know, you're going slow on multiple passes to get the cut through. And then the cork took about, just for one, took about 4 hours. So about 8 hours in total for one gasket, which is another reason why this is completely stupid and dumb. But, you know, everybody's going to ask, why didn't you just, you know, use an X-Acto knife? And I should have just used an X-Acto knife. I'll be 100% honest, that's what I should have done. But I got the idea in my head that I was going to cut it with a laser cutter, and once I got the idea in my head that I was going to cut it with a laser cutter, I did not stop until I was able to cut it with the laser cutter. And it took, as I said, 3 weeks of trial and error to get to the point where we're at today. And the cool thing about this unit, the SculptFun, is about $450 to $500. So 2 to 3 times more expensive than our other unit. But it has, the cutting area is way bigger. I don't know if you'll be able to see it. Let me see if I can scoot this thing over a little bit. But it has a huge cutting area. It's way smoother, way more stable. And on top of it, I have the kit. I have not installed it. You can double the length. So this thing is 450 millimeters by 500 millimeters, and you can take it out to 1,000 millimeters, where this thing will cut or carve or, you know, etch aluminum, giant pieces. I thought that I may need to go with the longer one initially to do the gaskets, and I found out for the V6 that this thing would do the gaskets perfectly as is. I'm not going to really go into very much more detail on this unit itself. If you're interested, I'll put a link down to the Amazon link down below so you can go check it out. And then if you just do like SculptFun S9 on YouTube, you're going to find 1,000 videos where people talk more about this stuff. The other thing that you're going to want if you're cutting through stuff is one of these cut boards, and essentially it gets the item up off the ground and gives it some space underneath for the laser to get through the item. If the laser is on just a tabletop or a cut surface, it's going to have a hard time as it gets closer to that surface. This gives it that extra room. That made a big difference in being able to cut. So that is all being said out of the way. Let me clean this up and we'll kind of talk about the last couple things here. Okay, finally, probably the most important part of it is the software. Now, all of these things come with their own free little default software. Most of them are junk. I've used the free software with my old one in the past. it was hit or miss. I broke down and bought Lightburn. If you looked into any lasers whatsoever, everything talks about Lightburn, Lightburn, Lightburn. And I've got it pulled up here, and I'm going to actually open up kind of my recent projects where you can see I have both gaskets, both the driver and passenger side on here. And then over here I have my pass counts, where in this case I was at 4 passes at 100% power at 1.5 millimeters per second. So very slow. Very slow. Thing moved very slow, took a long time. But that seemed to be what worked after making just so many cuts on like cork and things like that, finding out what settings worked for the fiber gaskets. That's what I finally settled on. Now let me show you kind of a quick thing of how I did this. I'm not going to go super in deep on here because I'm by no means an expert at light forge. I'm just smart enough to maybe figure this thing out. And so what I'd done is I took one of these gaskets and I went out and I scanned it on a scanner for a computer. And that allowed me to, Alexa's over there listening now. That allowed me to get a file that I could open up on here. And there it is. And you can see there's some spots on here that I took electrical tape and I laid over it to block off some of these holes. Like I blocked off the holes there, blocked off the screw holes, and I blocked off one of the water ports, which I really didn't need to do, because the cool thing that you can do after that in here is you can go in here and do trace image. And it's going to bring it up and show you kind of what your final image is going to be. You can play around with it. I don't know what half this stuff does, so I just kind of slide things around until I get something that I like. That's the wrong way. Let's go this way. And that's too much, so we can up the cutoff, which is going to, nope, we want to keep that down. Maybe it's ignore less than. We crank that up. Let's try 20. And then optimize. Let's take the optimization up. We'll crank the smoothness up. And we still got a lot of noise on there. Oh yeah, sketch trace is one that I did. Okay, that makes a big difference. And then we can adjust the threshold down until we get something pretty good. And you're just going to have to play around with these to find out what works for you. As I said, I don't remember what all I did because it's been a while. Okay, so that wants to be 100 higher. So we'll take it out to 100. We'll start with that just as kind of an idea. If you play around with this longer, you're going to get something better. We've got delete image after trace. We're going to clear the boundary out and hit OK. So now we've got this file that's kind of a base outline of where we're at. And then what I had to do after that was go in here and ungroup it so I could edit individual spots like this outer boundary. I want to delete that. And then I would come in and just draw lines and connect lines until I got what you saw was our final thing. Now, as I said, if you're wanting to do something like this, do some tutorials online for Lightburn, and eventually you can get to something like a final product by using a lot of the built-in features of smoothing and stuff like that. Like my port windows in here weren't the best shape, and so I went in and created a box that was the same size as them, and then kind of curved the edges off to make a nice smooth port edge on there. And then same thing with the windows. I measured where the water windows were in the gasket to go into the manifold, and just made them smaller, fit in there, and hopefully that will kind of get us where we need to be. It's a lot. We haven't tested it yet. It should work in theory based on what I know already, but we don't know for a fact. Fingers crossed. Let's look at the final step of the process. Last but not least was making the actual gasket itself, and for that I turned over to our buddies at Permatex using their high-tack gasket sealant. This stuff is amazing. Even though this has been drying for about 2 weeks now, because I was out, picking up Han Solo last week. If you guys know, I got the new dog. It is dry. There is still some residual tack on the stuff that was a little bit of a over, mess. Comes with a brush in here. And what you just treat it like any other sealant. Look at how gooey that stuff is. It's amazing. Brush it on, get your gaskets laid out, figure out what side's going where. And so in this case, if we were going from this to that, we would brush on a light coat on both sides, covering both completely, let it set for a while and tack up. And then we can line it up and make sure everything's lined up square and our gasket looks good. Do the same thing for the other side and then just compress it. Put some weight, doesn't take a lot of weight. We're just wanting to keep the thing flat so the glue adheres up. And whenever we finally get done, there's just a little bit of wobble in this one, but whenever it is mounted up to the heads, we can, use some tack to put it down to the heads. and it will flatten out whenever the manifold goes on. And we're going to have a nice cork gasket in the middle to compress down good sealing surfaces on both sides and have a leak-free gasket, hopefully. The only thing left to do, and what I'm going to do, is just throw some paint on the bolt holes that we need to mark out, because these bolt holes is not going to be the same. They're going to be down here kind of in the middle and then in a weird spot here. We're going to mark out the new bolt holes on this, and whenever I do that, I'll go ahead and measure out where they're at on the gasket. I can take those measurements into the program that I have and just make some circles that are the size of the bolt holes. You know, if they're a 14 millimeter or 12 millimeter or something like that, I can make the right size circle on that, plot it out on here, and if I ever have to make any more gaskets again for one reason or another, or if I want to go in and modify the design, if I get these installed and I figure out that there's something that needs to be changed on what's going on with this, I can go ahead and add the bolt holes, and those will get cut out whenever it's part of the process to make it a lot easier. And as I said, the nice thing about it is whenever it's all said and done, I have pretty much what looks like a manufactured gasket. I mean, I guess technically it is because I manufactured it, as opposed to one that I just cut out with an X-Acto knife. So it's a lot cleaner, it is reproducible, and you know, who knows, maybe somebody else down the road is going to be doing this project and they're going to need a set of gaskets, and they can hit me up and I'll see if I can make them one for a fee. I got to pay this thing off somehow, right? But not that much. I'm not going to charge you what it cost me to make these, which is about $600 all said and done, after all the materials, not even counting the time, but stuff like that. This is literally the most expensive head gasket, or intake manifold gaskets in the world. I challenge you to find more expensive ones and post them down below. I looked up all the Lamborghini and Ferrari ones. They're cheap in comparison. So that pretty much wraps up our latest and greatest project. Now I've just got to tear the intake manifold off, install it, and see if it works. Then we can finally get the Typhoon on the road and start, the tuning process, get it dialed in better. It's fairly dialed in for Rocky Mountain Race Week, but there's a lot still to do. Boost control, just diving into the fuel tech stuff, things like that. So once we get the thing where it's not smoking or having oil leaks and stuff like that, then we can get back to the process that we actually want to do, which is making power, learning how to tune, and having fun. But you guys know the drill. Thanks for stopping by the garage. Remember, ABT, always be tuning.